Welcome to Junior Cycle Week 10. So today we're going to be looking at linear patterns, and that's split into a couple of other categories. So we're just going to look at a couple of things to do with linear patterns first, and I suppose the first thing is to write down what a linear pattern actually is. So we're going to write down the definition for a linear pattern now, so you'll recognise it for again. So in a linear pattern or sequence, the difference or change between one term and the next is always the same number. Now, this means that the change in a linear sequence is constant. Which means the same value. Now, I'm going to show you an example of that. So, if we had a pattern 3, 7, 11, and 15. Now I'm going to label these. I'm going to label that term 1, so T1 for term 1, T2 for term 2, T3 for term 3, and T4 for term 4. Now if we look at the difference between each of the terms, so the difference, how do we get from 3 to 7? We added 4. How do we get from 7 to 11? We added 4. How do we get from 11 to 15? Again, we added 4. Now you can see there that it's the same difference each time. You're adding 4 each time, and because of that, it's a linear sequence. So if we look at the definition again, so in a linear pattern or sequence, the difference or change between one term and the next is always the same number. This means that the change in the linear sequence is constant, which is the same value. And if we look at the example there that I'm after writing out, you have the same difference in between each of the terms, which means that there is a linear sequence. Now I'm going to write out one more example of a linear sequence before we move on to kind of some question style examples. So I'm going to write out the linear sequence. So it's going to be 2, 4, 6, 8, 10. Now it's obvious that this is a linear sequence because there's the same difference between, you're going up in twos, but just to double check, we call that term 1, term 2, term 3, term 4, term 5. Now, how did we get from 2 to 4? We added 2. From 4 to 6, we added 2. From 6 to 8, we added 2. And then from 8 to 10, we added 2. So, we've the same difference each time, and it's constant, so that is also a linear sequence. So, both of those there are examples of linear patterns or sequences. So we're going to be looking at exploring patterns first, and I'm going to put up a question on the next slide to explain that. Okay, so I put up a question here. So the first 3 stages of a pattern are shown, and each stage is made up of a certain number of shaded discs and a certain number of white discs. So the first question here is to shade in the appropriate discs below to show the 4th stage of the pattern. So, if we look at the first stage there, how many discs do we see coloured in? So we see 1 disc that's coloured in there. On the second one, we see 2 discs that are coloured in. On the third disc, we see 3 discs that are coloured in. So we see a pattern forming here, and we're adding 1 each time. So 1 plus 1 is 2, 2 plus 1 is 3. 3 plus 1 is going to bring us to 4. So there should be 4 coloured discs for part 1 there. So I'm going to colour in the first 3 that we have coloured already. So we colour in the 3 and we add a 4th there. So that's to shade in the appropriate disc to show the 4th stage of the pattern. And again, I'll just explain that again. It went from 1 to 2, that was adding 1. It went from 2 to 3, that was adding another 1. So to add another 1, I'll go from 3 to 4, and you add it along like this because you've added it to the right. So you're doing the same thing there. Okay, so we'll go on to the second part. Complete the table below to show how the pattern continues. So the number of shaded discs, we know it goes up in ones. Now the number of white discs, let's have a look. So I'm going to use a different colour here just to be clear. So we've 1, 2, 3, 4, 5. We've 5 white discs in the first one. We have 1, 2, 3, 4, 5, 6, 7 white discs in the second one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 white discs in the third one. So let's see what's happening here. It's going from 5 to 7, that added 2. Then it's going from 7 to 9, that added 2. So if we add 2 again, it's going to go from 9 to 11. So there should be 11 white discs in the fourth pattern. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going up in 2s. So if we're to fill in the table here, we know that it goes from 5 to 7 to 9 to 11. Now we can do this out without having to draw out the pattern. 11 plus 2 brings us to 13, and then 13 plus 2 brings us to 15. So you're just adding 2 each time. In a particular stage of the pattern, there are 21 white discs. How many shaded discs are there in this stage of the pattern? Now, if you wanted to continue on the table, you could do it this way. So I'm going to do that up here. So if we had 7 shaded discs, so I'm continuing on from here. If we had 7 shaded discs, this would go up 2, so it would go up to 17. If we had 8 shaded discs, it would go up to 19, adding 2. If we had 9 shaded discs, it would go up to 21 white discs, and that's what you were asked in the third question. In this particular stage of the pattern, or in a particular stage of the pattern, there are 21 white discs. How many shaded discs are there in this stage of the pattern? The answer is 9. So then we are asked to write down the relation between the number of shaded discs and the number of white discs in each stage of the pattern. State clearly the meaning of any letters that you use. So we know from looking at the table that every time the number of shaded discs increase by 1, the number of white discs increases by 2. So we can write a sentence now to clarify that. So there are 2 extra white discs for each extra shaded disc. So we're going to write that down. So there are 2 extra white discs for each extra shaded disc. Now, before we go on to the next couple of questions, I just want to explain a different type of pattern that we can come across, and it's the opposite of linear, so it's non-linear. So when we have a non-linear sequence, the first difference, it actually changes between each pair of consecutive terms. So I'm just going to write that as a definition, just so we'll remember. So in non-linear sequences, the first difference changes between each pair of consecutive terms. Now, an example of that would be, so if I had 7, 8, 12, and 19. Now we'll do what we did before. We're going to label them. So that's term 1, term 2, term 3, term 4. Now let's look at the difference between each of them. So to get from 7 to 8, we added 1. To get from 8 to 12, we added 4. And then to get from 12 to 19, we added 7. So you can see there that that difference is not constant. It's not, you're not adding the same each time. So we actually call that the first difference. So we're looking at the first difference between each of the terms. So between 7 and 8, that's a difference of 1. Between 8 and 12 is a difference of 4. Between 12 and 19 is a difference of 7. So what we're going to do now is we're going to look at these differences as a first difference, and we're going to get the difference between each of those. So I'm going to use a different colour again here. So the difference between 1 and 4, how do we get from 1 to 4? We add 3. How do we get from 4 to 7? We add 3. So you'll notice that now the difference is the same, and this is called the second difference. Now there's a name for this type of pattern. When the second difference is the same, we call it a quadratic pattern. And the way you can tell that it's a quadratic pattern is if the second difference is constant or if it's the same. Now I'm going to write down here, when the second difference is the same, it is a quadratic pattern. And then the last type we're going to look at is if we have what we call an exponential. Now I'm going to show you an example. So an exponential is a pattern that involves doubling or tripling of terms. So if we had 10, 20, 40 and 80. Now you'll notice here, so we'll do what we did before. We're going to label each of these. So term 1, term 2, term 3, term 4. The difference between 10 and 20 is you're adding 10. The difference between 20 and 40, you're adding 20. And the difference between 40 and 80, you're adding 40. Now you'll notice that this is doubling each time. If you double 10, you get 20. If you double 20, you get 40. So, also you will notice that the second difference, if we were to get the second difference between both of those, so between 10 and 20, that's adding 10. Between 20 and 40, that's adding 20. So the second difference isn't the same, so it couldn't be a quadratic. So what we're going to write down is if the terms double or triple, the pattern is exponential. Now also I'm just going to add in a note there that the second difference is not constant. So that's another thing to remember. We're going to do an exam question now based on what I'm after going through there, so linear, exponential and quadratic patterns. Okay, so we're going to look at a question now, and it says to fill in the first difference and the second difference for the following patterns, and some of pattern 1 has been completed for you already. So pattern 1, it goes up, so it goes 2, 4, 9, 17, 28. So if we look at the difference, what's the first difference? So what's the difference between 2 and 4? So we know, how do you get from 2 to 4? You add 2, so 2. What is the difference from 4 to 9? It's 5. What is the difference from 9 to 17? That's 8. What's the difference from 17 to 28? So you get 11. So that's the first difference completed. Now the second difference is we need to get the difference from all of these. So how do you get from 2 to 5? You add 3. How do you get from 5 to 8? You add 3. How do you get from 8 to 11? You also add 3. So that's it. That's the first part done. The second part gives you a second pattern. So the second pattern goes from minus 1 to 2. So how do you get from minus 1 to 2? Well, you add 3. So the difference is 3. How do you get from 2 to 5? You add 3. How do you get from 5 to 8? You add 3. And how do you get from 8 to 11? You also add 3. Now, the second difference. The difference between 3 and 3 is 0. The same with the second one, 3 and 3. So the difference is 0. And then again, the difference between 3 and 3 is 0. So this brings us to the third part of the question, and it says, state whether the pattern is linear or quadratic. State whether each pattern is linear or quadratic and give a reason for each answer. So if we look at pattern 1, the first difference, it's not constant. It goes 2, 5, 8, 11. They're not the same. Now the second difference is a constant because it's the same difference between each of them and the second difference. So because of that, pattern 1 we say is quadratic. Now we need to explain that. So it's quadratic because the first difference changes, but the second difference is constant. Now for pattern 2, would we say it's quadratic or linear or exponential? So the first difference is constant, it's the same, so it's linear. So we say the pattern 2 is linear. And the reason being that the first difference is constant. So that's a very straightforward question, but it's important that you know the difference between quadratic, linear and exponential patterns. Okay, so we're looking at a higher level question now, and it's from 2019 paper 1. And this is to do with linear patterns or in sequences, but also bringing in algebra into it. So that's kind of what distinguishes it between higher level and ordinary level. So the first three terms of the sequence are, so term 1 is 6x minus 3, term 2 is x squared minus 2x, and then term 3 is 4x squared plus 3x. Now fill in the following table to write each of the first differences in its simplest form in terms of x. So what we're looking to do here is get the difference between term 1 and term 2. And the way you do that is you take term 1 away from term 2. So they've written it out here. So it's going to be x squared minus 2x, take away 6x minus 3. So it's just about being very careful here with your minus and plus signs. So I'm going to rewrite it here. So x squared minus 2x. Now we're going to get rid of the brackets. So minus, that's like a minus 1. So minus 1 by 6x is minus 6x. And be careful here, minus 1 by minus 3 is a plus 3. So that's gotten rid of the brackets there. So then what we're going to have is we're going to put the x squareds together, the x's together, and the numbers together. So for that, it's going to be, we're going to bring down x squared here because we know they're x squared terms, so we can get rid of that. Minus 2x minus 6x is minus 8x. And then, so we got rid of them, and then we're bringing down the plus 3. So that's the first difference between term 2 and term 1. Now we're going to have to do the same for term 3 and term 2. So term 3 minus term 2. So term 3 is 4x squared plus 3x. Take away x squared minus 2x. So we can take the first term out of the brackets because there's nothing in front. So 4x squared plus 3x. And we imagine that this is a minus 1. Minus 1 by x squared is minus 1x squared. Minus 1 by minus 2x gives you a plus 2x. So then we're going to take each of the items down to the next line. So we look at the x squared first. So I'm going to write down minus x squared or minus 1x squared. So dealt with that. The x is next. So 3x plus 2x gives you 5x. So we'll get rid of them. And actually I forgot to bring down the 4x squared, so I'll bring that down here. So we can actually shorten it even more. 4x or minus 1x squared plus 4x squared is 3x squared. So they can go, and we're bringing down the 5x. So that's the second difference. So the difference between term 3 and term 2 is 3x squared plus 5x. Okay, so part B involves a little bit of thinking here. So it says, show that if the terms form a linear sequence, then 2x squared plus 13x minus 3 equals 0. So don't worry about this for the minute. We need to show that the difference between first difference 1 and difference 2 is the same. So that would be equal to that if it's the same difference. So we're going to write an equation now. It's going to be x squared minus 8x plus 3 is equal to 3x squared plus 5x. And the reason I've let them equal each other is because it's the same difference if it's linear. Okay, so if it's linear, this is equal to this because the difference must be the same. So if we brought everything over to one side, so I want to bring all of this over to this side. So when I do that, it's going to be 3x squared plus 5x minus x squared plus 8x minus 3 equals 0. So I'll just explain what I'm after doing there. I'm after bringing all of these terms over to this side. So this became a minus, This became a plus and this became a minus. So we look at the x squared terms next. 3x squared minus x squared gives you 2x squared. 5x plus 8x is 13x. And you're only left with minus 3, so bring that down. And if you look back up, 2x squared plus 13x minus 3 equals 0. That's what we have here. So it was just a case of letting the first difference equal the second difference. It must be equal if the sequence is linear, then the difference must be constant. And I'm going to write that along this side just to help us remember. So if the sequence is linear, the first difference must be constant. And that's why I let them equal each other. Before we go on to the next question, I'm going to go through the general term of a sequence or a linear sequence. And it's an algebraic formula that you'll get in your log tables that works for any linear sequence. Now, what you will get in your log tables is as follows. So Tn is equal to A plus n minus 1 by d. Now that's what you're going to see in your log tables. So I'm going to explain that. And I'll explain that using an example. Okay, so the example is find the general term of the following linear sequence. So 15, 11, 7, 3. Okay, so if we were to look at this formula, this is basically coming up with a general term in which you can put any value for n into. Okay, so we're just going to look at each of the components. So A is always your starting term. Okay, so A is always the starting term or first term. D is the common difference. And n is the term number. Okay, so we're going to apply this. Now, if we were to look at the general sequence that we're given there in that example, this is term 1, term 2, term 3, term 4. Now, we're also going to get the difference between each term. So how do we get from 15 to 11? We took away 4. How do we get from 11 to 7? We took away 4. How do we get from 7 to 3? We took away 4. So D, which is the common difference, is minus 4. Now be careful there because you're taking away 4, not adding it. So D is minus 4. A, which is the starting term, is 15. So it's 15 in that case. Now we're literally going to plug this into the formula. So Tn is equal to A plus n minus 1 by d. Now what I like to do here, I think it makes it a lot easier, I bring the d in front here because you're multiplying d by n minus 1 anyway. So I bring it in front and I put n minus 1. So I'm just bringing it in front because you're multiplying it anyway. So let's fill in what we have. We have A is 15 plus d is minus 4 by n minus 1. So let's expand that out. 15, now a plus and a minus give you a minus, so it's going to be minus 4 by n is minus 4n. And minus 4 by minus 1 is plus 4. So we can shorten it down now. So Tn is equal to, so 15 plus 4 is 19, so it's going to be 19 minus 4n. Now what that means is if I wanted to get, we'll say, the 30th term, so we have the first 4 terms. If I wanted to get the 30th term, I wouldn't have to keep going till I get T30. I could literally just plug it in here. So T30, I'll just show you here. So T30 would be 19 minus 4 by 30. So you'd put in whatever n is, whatever term you want is n. So you put it into the formula and you'd be able to get what your 30th term would be. So you're putting in 19 minus, so 4 by 30 is 120. So then when you put into the calculator 19 minus 120, you'll get minus 101. So what that means is the 30th term is minus 101. So it's a very straightforward formula to use, and you will get that in your log tables and you can apply it to any linear pattern or sequence. So I've pulled a question here and it's from paper 1 2015. So if we look at the question here, so a boxer runs up the stairs as part of her training. She can go up 1 step or 2 steps with each stride as shown. The boxer wants to count how many different ways that she can reach the nth step. She calls this Tn, which is the nth Taylor number. For example, she has 3 different ways to reach the 3rd step as shown in the table below. So the first way she can do it is up 1 step, then 1 step, then 1 step. So she can go from 1 step to 1 step to 1 step. That's the first way. The second way that she can do it is go up 1 step and then 2 steps. Or she can do it a third way, go 2 steps and then 1 step. So there's 3 different ways that she can do it. Now the first question there is find the value of T1 and T2. So the question is that you're being asked here is how many different ways can she reach 1 step? And the answer is 1. She can only get to the first step 1 way, and that's by going up 1 step. So T1 is 1 because it's 1 way to reach 1 step. Now, if we were to look at for T2, okay, so how many different ways can she reach the second step? So the second step, she can either climb 1, 2, like that, so 1 step and then 1 step, or she could climb 2 steps together, like so. So for the second step, how many different ways can she reach the second step? So there are 2 ways. T2 is equal to 2. So the ways that you have is 1 plus 1 step, 1 plus 1 steps, or 2 steps at a time. For part B, list all of the different ways that she could reach the 4th step. 1 way is already done for you, hence write down the value of T4. Okay, so how many different ways could she reach the 4th step? So I'm going to draw the stairs here. So 1, 2, 3, 4. So how many different ways could she reach the 4th step? The first one is done for you. So she went 1, 2, 3, 4. So that's 1 way. Now she could also go up 1, 2 and then jump 2. So that would be 1 plus 1 plus 2. She could also go 1, 2, 1. So she could go 1 plus 2 plus 1. She could also go 2 steps at a time first. So 2 and 1 and 1. So 2 plus 1 plus 1. And there's one more way she could do it, and that would be to jump 2 steps at a time. So 1, 2. So 2 plus 2. So if we look closely here, we have 1, 2, 3, 4, 5. We actually have 5 ways to get to the 4th step. So that's the answer to that. So I'm going to attach some useful links to extra video tutorials and extra exam questions. I go back over the different types of patterns that you can have, so linear, quadratic and exponential, and go back over the formula from the log tables as well, as that comes in really handy once you kind of start doing exam questions. So I will speak to you next week.